two d's here and only a single y, but in the bottom you got dx and dx, so that would be dx squared there. So that's sort of where the notation kind of follows from. But it's pretty much always just going to it's going to say find d squared y over dx squared, so you can remember which square is in the right place there. All right, so this first question asks us to find the second derivative for x squared plus y plus 3y squared equals 10. Give your answer in terms of x and y. So before you can find the second derivative, you've got to do the first derivative, which is what we've just been doing with our implicit differentiation. All right. So the derivative of x squared would be 2x. The derivative of y is just 1, but we have to put a dy dx with it, plus 6y dy dx, and this would equal 0. So when we're doing implicit differentiation, we want to now move everything without a dy dx over to the left or to the right hand side. I'm going to go ahead, if it's okay with you guys, and factor out the dy dx of the stuff that's left over here. So what would I get when I factor out the dy dx? 1 plus 6y, and then that'll equal negative 2x, and I will divide by 1 plus 6y. Okay, so my first derivative is negative 2x over 1 plus 6y. Okay, it's really important that you get the first derivative correct before you try the second derivative, because if you get this wrong, then your second derivative is definitely going to be wrong. So whenever you get to homework for tonight, I have posted on Canvas the first derivatives of all of the functions, so you can check your first derivative before you go on to solve for that second derivative there. So we've got our first derivative. Now we need to take the derivative of the derivative. So when we take the derivative over here of dy dx, we get the second derivative. This is that d squared y over dx squared. On the right-hand side, we need to use the quotient rule to take our derivative here. So we would have low, 1 plus 6y, derivative of the high, it's negative 2, minus high, d low. What's the derivative of 1 plus 6y? 6 dy dx over low squared 1 plus 6y squared. Now, the problem with what we have here is we have a first derivative in our definition of the second derivative, all right? And the question here says, give your answers in terms of x and y. That means it cannot have any, our answer cannot have any variables in it besides x and y, meaning that we cannot include dy over dx in our answer, right? We can't have that there. So, what we can do, because we've got this dy dx here, we can replace it with that first derivative that we just found. However, I think I am going to clean this up just a little bit first before I replace it. So if I distribute here, I will get negative 2 minus 12y, and that's going to be plus 12x dy dx over 1 plus 6y squared. And if I replace here this dy dx with the derivative, So I've got negative 2 minus 12y plus 12x times negative 2x over 1 plus 6y over 1 plus 6y squared. Okay, now, technically, FRQ, you wouldn't want to go past this, right? This is fine. You could stop. That complex fraction is okay. However, more than likely, you are not going to see an answer choice where they leave that 1 plus 6y in the denominator of that top fraction. You're not going to see that complex fraction left. So, like many of the others, the hardest part of this really comes at the end in the simplification. So, I could write this like this, negative 2 minus 12y minus 24x squared over 1 plus 6y. Oh, I put the square in the wrong spot on that last one, didn't I? That right there, I think, know what I know now. I think is a linkage error and will cost me a point if I had that square on the inside of the parentheses instead of the outside, if the grader caught it. Even if I fix it down here. So, be careful. Alright, so you got a couple ways to deal with this. You could either multiply the top and the bottom by 1 plus 6y. Or you could like get common denominators here. I think it's a little complicated to think about multiplying top and bottom by 1 plus 6y and distributing that because it's two terms. So I think I'm going to do common denominators, but it could be done either way. So if I do common denominators, this has to be 1 plus 6y, which means I got to multiply by 1 plus 6y here. And this would be 1 plus 6y, which means I would multiply by 1 plus 6y here. So that is going to give me negative 2 minus 12y minus 12y minus 72y squared minus 24x squared over 1 plus 6y. Since you got all the same denominators there, you can write that over just that single denominator, and then this is still over 1 plus 6y squared. And I'm going to write this as 1 plus 6y squared over 1 right here. So, dividing fractions is easy as pie. Flip the second and multiply. So I'm going to combine here in the numerator what I can combine. So I've got negative 2 minus 24y minus 72y squared minus 24x squared over 1 plus 6y times 1 over 1 plus 6y squared. And then since these, of course, have the same, or not the same denominator, but the same base right here, and we're multiplying, we can just combine those. And probably they're going to factor a negative 2 out of that numerator, I would imagine. So negative 2, we got 1 plus 12y plus 36y squared plus 12x squared over 1 plus 6y cubed. So you can see that those can be very involved, especially in the simplification, because if I zoom back out here, ooh, that's a lot there. Okay, questions? I will say these can be difficult to get the correct answer on because of the length of the problems. So when you get to homework, first of all, check your first derivatives with the key that I have put up, because if you're trying to find the second derivative and your first derivative is wrong, then there's no way you're getting the right answer. And then, do your very best on those, but these are pretty difficult problems. Here. All right, let's look at the next problem. All right, again, same directions. We're finding the second derivative. We've got 3xy plus 2x squared equals 10y. Give your answer in terms of x and y. So we got to do the same thing. We got to find that first derivative. We've got to plug in. We got to take the derivative again, and then we'll have to plug that dy dx in that we have. So, who can tell me what to do right here? This 3xy. Got to use the product rule, okay? It is so easy to forget that you've got to do the product rule there. A lot of students will tell me 3 dy dx, because the derivative of x is 1, the derivative of y is dy dx, 3 dy dx. You must use the product rule because x and y are multiplied there. That didn't happen on the last one. Must do that here. So you got 3, and then I'm going to have x times the derivative of y, which is dy dx, plus y times the derivative of x, which is just 1 there. Then I move on to my 2x squared. That's just 4x. And my 10y, that's going to be 10 dy dx. So I'm going to distribute my 3. So I got 3x dy dx plus 3y plus 4x equals 10 dy dx. Okay. Everything with a dy dx needs to go to the left. Everything without needs to go to the right. I'm going to go ahead and factor out my dy dx as I do this. So I'll have 3x minus 10 over here on the left-hand side. And then I'll have minus 4x minus 3y on the right-hand side. And I will divide by 3x minus 10. So my derivative is going to be negative 4x minus 3y over 3x minus 10. Okay, on the homework at this point, check and make sure you got this part right, because if it's not right, the next part's going to be wrong. Hopefully I've done everything right. Nobody sees any mistakes I've made, hopefully. Okay, so second derivative, we'll have d squared y over dx squared. We're going to take the derivative using the quotient rule here. So we'll have 3x minus 10 times the derivative of the numerator. Derivative of negative 4x is negative 4. The derivative of negative 3y will be negative 3 dy dx. So that's low d high. We got to do high, negative 4x minus 3y. Derivative of the low, this is just going to be 3, all over low squared. Alright, so now you got some options on what you can do here. As far as, we're going to have to plug in the dy dx and get rid of this. I see what I would do. Question is would you guys see it? What would you guys do? Tell me what you guys would do. Okay, so like this, 3x minus 10, negative 4 minus 3, negative 4x minus 3, y over 3x minus 10, plus 12x plus 9y, all over 3x minus 10 squared. Okay, we can do that. That's fine. What would you guys do next? If it is free response, you can leave it here. So you would not have to simplify further if it was free response. You cannot leave it here because you still have the dy dx, but you could leave it here if it's free response. So I'm going to mark that here. On a free response, this is okay. If they don't ask you to do any simplifying, and they won't on a free response, past that, you could stop here. They might ask you to plug in a number, which might make it easier to simplify. Easier if it's simplified, but so FRQ, we could stop here. What do you guys think now? What? This 3?
Yeah. And then find common denominators.
Okay, with what?
With 3x minus 10.
With the whole thing, or just in this parentheses? What are you saying, Connor? This 3x minus 10 right here is multiplied by this stuff right here. So we can do what you were saying, Bo, but because this 3x minus 10 is the denominator over here, we don't usually do this because we usually do like distribute the 3x, like we usually FOIL that, right? Like if we had done this up here, we could have FOILed. We could have FOILed before we plugged in. But we can also think of it like this, like we're distributing that whole 3x minus 10 to both terms. Okay, so if we do that, and I think this is going to be our easiest route, if we do that, we would have negative 4 times 3x minus 10 minus 3 times 3x minus 10 times this negative 4x minus 3y over 3x minus 10. We'll still have our plus 12 plus 9y, 12x 9y, all over 3x minus 10 squared. And the reason that this is nice is because this 3x minus 10 cancels with this 3x minus 10, which gets rid of your denominators. And so at this point, you can just distribute here. So you'll have negative 12x plus 40. And then this 3x minus 10 is gone. You're just distributing this negative 3 over here. So you'll have plus 12x plus 9y plus 12x plus 9y over 3x minus 10 squared. you can have a negative 12x can cancel with this 12x, but you do still have a 12x there, so you'll have 12x plus 18y plus 40 over 3x minus 10 squared. And something like this is what you're more likely to see in the back of the book. Yeah. Okay, let me give you a minute to look back through that, see what questions you have.
A lot of the terms repeat. Is that a thing that happens a lot when you do second derivative?
Yes. You will, a lot of the time, both see, particularly whatever, like the denominator of your first derivative is, a lot of times you'll see that still as part of your second derivative. So like right here, we just had 3 minus 10x squared. On the last one, it was like to the third power, but we still have that. So you'll see that happen a lot. All right, questions? All right, this is the last one we're going to do for a warm-up. Okay, so we've got xy plus 3 cosine y, and this equals 0. And we are supposed to find the second derivative at 3 over pi. Okay, and let's see, when I work this one out, I think I'm going to make this one calculator active. I think when I worked it out, I decided that this would probably be given to you calculator active. So grab your calculators there. All right. So, for this problem, we are going to take the derivative here. Zach, when I take the derivative of xy, what am I going to get?
Get x times dy dx plus y.
Perfect. Okay. How did Zach get that? What did he use? Product rule. You have to use a product rule there. You're multiplying an x and a y. It's one of the things that gets students the most on these problems. Just regular or second derivative, either one, because it looks so simple, it doesn't feel like you need to use a special rule on it. But make sure you use product rule there. And then we've got to do the derivative of 3 cosine y. Braden, what do we get when we take that derivative? Negative 3 sine y. Anything else? Times dy dx. Times dy dx. Because it's kind of like a chain rule. You're taking the derivative of the cosine, and then the derivative of the y on the inside is dy dx. So it's all multiplied together. And this will equal 0 here. All right, here. All right, so we are going to keep everything with the dy dx over here on the left-hand side, which is my x and my negative 3 sine y. I'm going to go ahead and factor that dy dx out. I'm going to move the y right here over to the other side, which will give me a negative y there. And so if I divide, I will get dy dx equals negative y over x minus 3 sine y. Okay. All right, so we have our first derivative. Now we need to take our second derivative. You'll see that most of your second derivatives are going to require a quotient rule on this, as this one does also here. So I'm going to take the second derivative, and that will be low, x minus 3 sine y, times the derivative of the high. What is the derivative of the top? Negative dy dx. Make sure you either use a multiplication sign there or parentheses so it doesn't look like you're doing minus dy dx. In fact, let's do some parentheses. I like this a little better. Minus high times the derivative of the low. Derivative of x is 1. Derivative of negative 3 sine y is going to be negative 3 cosine y, but this is going to have a dy dx with it, all over x minus 3 sine y squared. All right, so let me tell you that simplifying this is going to be very difficult because you've got two places where you have to plug in this y over x minus sine y, or x minus 3 sine y. It will cancel over here, but it does not over here, and then you got common denominators, and you got a bunch of stuff that you have to do, right? However, they did not ask us to give this in a simplified form with x and y. They asked us to plug in a number here, right? We're plugging in the coordinates 3 over pi, pi. So, if they have asked you to plug in a number, I would not simplify, right? What I would do is I would find the derivative, the first derivative, where x, y equals pi over 3 minus pi. I'm sorry, what was it? Never mind, they're both positive. Pi over 3 pi. Okay, so the first derivative here, I'm sorry, it is, thank you. Over pi. And so our first derivative, which is this, we're going to have negative y, so negative pi over x, which is 3 over pi minus 3 sine of pi. And because this is calculator active, I'm just going to do that on the calculator. It can be done without the calculator. It just gets a little extensive if you do it without the calculator. So you got a couple options here. If they've asked, if it is multiple choice, look at your answer choices. If your answer choices have pi, you need to stick with pi's. If your answer choices are decimals, stick with decimals. If it's free response, do whatever you feel like. It doesn't matter. Okay? So this is negative pi squared over 3. Or if we want to do a decimal for this, we just have to hit the green button before we hit enter. and it'll be negative 3.28987. I'm going to store that value right there as an A, so that it'll be easier to type in if I decide to use the decimal. So I'll do both ways. You guys decide which one you think is better. So if I am plugging in, I notate that I am plugging in by putting that line x, y equals 3 over pi, pi. And so you are plugging in pi for your y, 3 over pi for your x. So you got 3 over pi minus 3 sine pi times, if we're going negative pi squared over 3, minus, I'm going to go ahead and just make that a plus y to make it easier. So plus pi times 1 minus 3 cosine pi times pi squared over 3 over 3 over pi minus 3 sine pi squared. It is the negative pi squared over 3. It's that derivative at that point. I'm going to tell you what, it's just going to be easier to do decimals for sure, isn't it? Because typing this in is going to be very difficult with all of your parentheses. So here, I've got A equals negative pi squared over 3, which is negative 3.28987. I stored that in my calculator, right? I've got, I'm going to let B equal pi, 3 over pi. I'm going to store both of those in my calculator. 3 over pi, which is 0.95493. Alright, so I'm going to store that as my B. I've told you guys about storing before, right? You guys know? Okay. Alright, so I've got both of these stored. If you're going to do this, you want to store those values. You don't want to do the rounded values. So what I can do is whenever I type this in, I can do B minus 3 sine pi times A plus pi times 1 minus 3 cosine pi times A over B minus 3 sine pi squared, and that is going to make it easier to type it in here, because it's going to get messy typing it in. So if I do B minus 3 sine of pi, and make sure right here when you type in B minus 3 sine pi, sine is going to open up a parentheses for pi. You got to close the parentheses for pi and then close the parentheses for the expression here, right? It's putting that extra, anytime you have that sine pi, the calculator makes you put that extra set of parentheses there. So you want to make sure you get both of those closed. And then we'll multiply that by A plus pi times 1 minus 3 cosine pi times A. Alright. I'm going to hit enter and get this numerator first because I feel not confident that I can type the whole thing in there. So let's check and make sure that looks okay. Alright, we got negative 31.0063. That's just my numerator because I only typed it in. And then in the denominator, I'll do B minus 3 sine pi.
A times B minus 3 sine pi times A, that A is supposed to be negative. Because it's negative dy dx. So that should be constant.
Daggone it. Alright, let's fix it. It should be negative. It needs to be negative. Negative A. Is that what you got? For the just the numerator, or did you do just the numerator?
I typed it in the entire
Okay. Alright, let's see if we get the same thing in the end. Alright, so I got negative 24.8647 now. Alright. So B minus 3 sine pi. Make sure you close both of those parentheses before you square it. Alright. 0.9118. I'm not going the same thing as you. You got 16, I think. Alright, negative 27 point. Okay, there's a way for us to check to see if any of us are right. Desmos. Let's check it. Okay. Let's see if any of us are right. Okay, so we know our original equation was xy plus 3 cosine y equals 0. Oh, that's cool. I like that. Okay? Alright. Then, our tangent line is at the point. No, we can't check this. We can't check it because we can't do a tangent line.
Where's 3 over 5? Where's the point?
Our point is at 3 over pi.
I could probably argue which one is best.
Pi. Well, here's our problem, is that we're looking at the second derivative, not the first derivative. So we could do the tangent line. Like we could make sure our tangent line, we could make sure it is correct. We could do y equals, we'd have to use this first derivative, which is negative 3.2897 times x minus 3 over pi plus pi. And we can see we got that part right. But we need to be doing the derivative of the derivative. Maybe. Maybe. So, if we type in the equation for the first derivative,
Negative y over x minus 3.
would we call it y? I think we have to for this. See, our point's not even on the derivative, though. Our point would be 3 over pi, and then that negative pi squared over 3. No. Alright, because our y coordinate would be our second derivative. Did I type that in right? We might have to count all off with you.
Maybe we should Google how to find second derivative on decimals. I put it in the math way as math way for
I think it'll give you.
Oh yeah, let's watch a 4-minute YouTube video.
Not using Grammarly. The great thing is, Grammarly is community. They not only check your grammar, but for this week's.
I just want to see what he does.
Powerful.
So you got that'll work with a function, but I don't think it's gonna work with a implicitly defined function. Alright. My question has become I need to verify. Okay. You guys get the idea of the process, although the process became more complicated than I had intended for it to
Is this going to
become.
Is that one going to be on our homework? Questions like that?
The ones on the homework do not ask you to plug in a number. The reason I wanted you to do one where you plugged in a number because these show up on the like exams sometimes. But I made this problem and I got it to work, I thought, and maybe I got that answer I didn't write down there. I didn't keep it. I did it on a scratch sheet paper and threw it away, which was a mistake. If I got the same answer twice, I'd feel more confident about it. But the process of this, you guys get the idea of plugging this number in instead of having to like simplify. The ones on the homework do not ask you to plug this in. I wanted us to do one because you're going to see it on some free response questions. I have low confidence in my answer. I'm going to go back and look at it here while you guys start your assignment. So your assignment is on page 180. It is 49 through 54. And on Canvas, I have posted the first derivatives for these.
I put the entire thing that we had in there all at once, and my calculator got 13.2283. I just did the exact same thing. I got 13.2283. I don't know if that's actually the derivative, but that's the answer that you get.
All right, I'm going to come look at yours real quick. All right, so I put the first derivatives for all of these because the book is not going to give you the first derivative. It just gives you the answer. So I would suggest that you check your work with these that are posted on Canvas with your first derivative before you move on to the second derivative. Because if you try the second derivative with the wrong first derivative, then your efforts are futile. You're not going to get the answer.